those lessons in the Saxon book. It is another review lesson, and because it's review, they think it's totally a great idea to put a whole bunch of review things in one lesson. So this is not anything new, but it is things that you have seen before. Equations of lines, rationalizing denominators, completing the square. So I want you guys to look at the graph that I have up here, and what are some things that you can tell me about the line that you see up here? This is review. So what are some things that you remember about lines like this? Ronald? Okay, y-intercept is -2. Something else that we remember. Emily? It has a positive slope. Shane? Slope is like 1/2. Can anybody put that together and give me an equation for that line? Anybody remember how that stuff works, Blake? Which is for this line? Okay, excellent. So we're remembering the y equals mx plus b. And what if I take this green line, and let me try to find a good place to put it here. Well, where'd it go? So let's put that, I don't know, how about right there? Tell me some things about the green line. What does it look like to you guys? Maggie? Okay, it looks like it's parallel, so we're going to assume that it is. So parallel, so same slope. So can anybody give me an equation for the green line? So Jumpy?
Y equals 1/2 x plus 1.
Okay, same slope, different y-intercepts. What if I pull out another line here? And tell me what you're thinking about this red line while I find some sort of place to put it. I guess that's about as good as anywhere. What does that red line look like to you, Mia? Okay, it looks like it has a negative slope instead of a positive slope. What else does it look like, Keith? Looks perpendicular. So anything more you can tell me if it is a perpendicular line besides just that the slope is negative? Can we come up with anything else? Ashani? Okay, so how did you come up with the perpendicular slope was -2? It is, so we change the sign from positive to negative, we turn it upside down, or we take the reciprocal on that. So you guys have done a great job of remembering the things that we want to add to our formula list here. You have remembered that lines can be written y equals mx plus b, where m is the slope and b is the y-intercept. There is another form for equations of lines that we may not have worked with a whole lot here at this school in our program, but it is the point-slope form of a line. And sometimes it's a whole lot easier if you use that instead of automatically doing everything with mx plus b. Point-slope is what you will use if you know the slope and you know some point x1, y1 that is simply some point somewhere on that line, whatever its coordinates are. If you know the point and the slope, then you can write the equation in point-slope form, which is y minus that known y coordinate of the point equals m times x minus the x coordinate of the point. So when we had our equations on the other page where y was equal to 1/2 x minus 2, I think it was, we had a general x and y in that formula, so then we could take any point on that line and plug in for this x, y, and get something true. In this one, this y and this x are that general x and y. These two are numbers. They are the coordinates of that point that you know. You guys have also done a fabulous job for me of remembering that our perpendicular slope is take the opposite, turn it upside down, so the opposite of the reciprocal, and that parallel lines have the same slope. Another thing that I suspect you remember quite clearly, but we just haven't talked about yet, how do we get the slope? If we have a line and we know some points on that line, how do we figure out exactly what the slope does equal? Callum, you think you remember? Rise over run. How else do we describe it or calculate it? Anybody who hasn't answered yet, I want to try to give that a shot. If we have some points on a line, how do we come up with the slope? Caitlin? Change in y over change in x. So if I know what the points are, x1, y1, x2, y2, change in y, I subtract the y's in the numerator, subtract the x's in the denominator. It does not matter which point I pick first, but what does matter is these two are from one point. If you start with one point in the numerator, you start with the x-coordinate of that same point in the denominator. You cannot do it one way in numerator and one in the other. These two both come from the other point. Now, to make a connection between this and your point slope formula up here, if I said instead of m is y2 minus y1, I just said y minus y1 over, instead of x2 minus x1, I just said x minus x1. So you see how that fits with our definition of slope. If I then took the cross product, I would have y minus y1, and I would have m times x minus x1. So just to kind of help remember how that goes. So does everybody have our formulas down? Any questions to that point? Okay, let's do some examples and see what you managed to remember. I need some help. I need an equation. I've got some line. I've got some other point. I don't know anything about slope, and my formulas both talked about having to have slope. So what is going on here? Help me figure this thing out. What do I need to do? I need to see hands going up. I need to see ideas from you guys. What do you want to try first here? Emma.
First we have to get the parallel equation.
So tell me how I'm going to do that. I'm going to do it minus 2x plus 8. Okay, so you wanted us to isolate y so that we have y equals negative a half x plus 2. So, okay, now I need to know how in the world that's going to help me. That means I have a line that's, I don't know, doing something kind of like that. And I'm supposed to end up with a parallel line. I'm not sure exactly where that is. Maybe something like that. How does getting that equation of the blue line help me get the equation of the red line? What do I need to do now? You've been doing these for a couple of years. Help me out. What are we going to do next? What's the next step going to be? Hope? Into this, 6 isn't going to equal negative 2 plus 2. Okay, so I know that my red line has a y equals mx plus b equation. And then what else are you putting into that?
Like your 6 for y and your 4 for x, and you already have your slope and length going in parallel.
Oh, so first, because, very good, because they're parallel, this slope is also going to be negative a half. So we can put a minus a half here, and then don't do something like I do. Don't say just because 4 is first, I'm going to write it first. Pay attention. 6 is the y, x is the 4, and we can solve and get what b is. Nothing at all wrong with doing that, but this one has an easier way. Did this say get the slope-intercept form of the equation? Did it just say get an equation? We could simply say we're going to use, since we know the slope and we know the point, we're going to use the point-slope formula. So we could simply say y minus this y coordinate equals the slope times x minus the x coordinate, and we could be done. It did not say which form, so we didn't have to do that other way. Not wrong if we do it. Let's just make sure we get the same thing. So if that was a negative 2, if we add the 2 to both sides, b is 8. So y equals negative a half x plus 8. Do we get the same thing if we distribute? Minus a half x. So far, so good. And then we have minus a half times minus 4 is plus 2. And if I add this 6 on both sides, I have y equals negative a half x plus 8. So they are indeed equivalent equations. Anybody with questions on that one? Let's try one more before we move on to other things. What do we do now? What's going to happen with this one? Mia? Wow, excellent talking me through the steps there. So we isolated y to figure out what the slope was for the original line. Original line had a slope of negative 4/3. Since we are doing a perpendicular line, we needed to take the opposite of that and turn it upside down, take its reciprocal, so we're going to use the slope of 3/4. So now let's get an equation. Do you want to do slope-intercept or do you want to do point-slope? Why? It's shorter, it's less work. We already know the slope and we know a point. So it didn't specify. So let's do y minus our y coordinate of 5 equals 3/4 times x minus our x coordinate of negative 2. So times x plus 2. And that is an equation of the line. And like before, if we needed y equals mx plus b, if we needed slope-intercept form, we could distribute and get there. Or we could have taken this for m, plugged in this, and solved y equals mx plus b to get what b is. So depending on what you're asked, you may have a choice of methods. Thumbs up, thumbs down. Do we feel pretty good with remembering how lines work? Okay. Then next topic that Saxon wants us to review today. We have a denominator that is not a rational number. It's got a square root, so it is irrational. We need to change it around so that the denominator is a rational number. This kind is harder than if it just had the square root of 3. This denominator has 2 terms in it, 2 minus 5 root 3. Is there anyone who remembers the process for rationalizing this denominator? Ryan? Yes, we multiply numerator and denominator by what is called the conjugate, which means we keep the first number the same, we change the sign, take the opposite of it. This was minus, so we use plus. If it had been a plus, we'd use a minus, and we keep the second term. We then think of those as if they have parentheses, and whenever you do parentheses times parentheses, you have to FOIL it. So let's FOIL the numerator. 1 times 2 is 2. 1 times 5 root 3 is 5 root 3. Root 3 times 2 gives us plus 2 root 3. Root 3 times 5 root 3 gives us plus 5. Root 3 is a regular 3. So our numerator, 2 plus 15 is 17. 5 root 3 plus 2 root 3 is plus 7 root 3. I don't know that that's any better than the original numerator. It's still irrational, but we don't really care about numerators. It's the denominator that has to become rational. What is nice about this, and this is the reverse of our factoring pattern of x squared minus y squared, the o's and the i's are going to go away when we FOIL the denominator. So 2 times 2 is 4, plus 10 root 3, minus 10 root 3. So those cancel out. After this, I won't even bother to write the o and the I when I'm doing these. Minus times plus gives me a minus. 5 times 5 is 25. Root 3 is a regular 3. So that gives me minus 75, and plus 4 is a minus 71. So I am almost finished. Who remembers the last little adjustment we need to make? Hope? Okay, we don't like to leave negative signs in the denominator, so there are a couple of ways that we can think about this. If you want to think about it as multiplying numerator and denominator both by -1, then it simply switches and you've got a negative 17 minus 7 root 3 over a positive 71. You switch all of the plus and minus signs, numerator and denominator. I think that's the easiest way to get there. You could, however, also split it up as 17 over negative 71 is a negative number. Plus 7 root 3 over negative 71 is again positive over negative. 7 root 3 over 71. So either of those forms I would accept. I like the second one better for this kind of problem. Questions there? Yes? Do you have to write the -1 over -1? Is that just... I'm sorry, a little bit louder still. You could do that. It's most of the time it's better to go ahead and put it in the numerator and switch all of the signs as you go through it. Okay, our other kind of denominator to rationalize is this. We have an imaginary number, so that denominator isn't real. If it isn't real, it's not either rational or irrational, so it's not rational. We've got to get it to where it's some kind of a rational number. Who remembers how we do that? It's actually more or less the same process. Caleb? Which would be? Okay, there are two ways we could do this. I'm going to do it the technically correct way. This technically should be -2 minus 3i to write that complex number in the correct order. So then I'm going to multiply it by -2 plus 3i over -2 plus 3i. So I am multiplying numerator and denominator by the complex conjugate for the denominator. And I'll talk at the end, if we had done it by minus 3i plus 2, we would get the same answer, but with the work being just a little bit different along the way, and I'll talk about that at the end. So, if we multiply the denominator then, that's going to be very nice, because now I'm doing -2 minus 3i times -2 plus 3i. So minus 2 times minus 2 gives me 4. Minus times plus gives me minus. 3 times 3 is 9. I times I is I squared. But what is I squared? Negative 1, so that becomes 4 plus 9, or 13. So far, so good. What do you want to do about this numerator? Because now we need to multiply my original numerator by this complex conjugate. So what do we want to do with that? Sharon? Or no, Mia. Sorry. Unless Sharon really wants to. I'll let Mia take it. Let's simplify that original numerator before we go any farther. Let's make the problem easier. So I'll let you guys split it. So Mia, what's I to the 4th? So we've got 4 minus 1. Sharon, what's I squared? So this gives us a minus 2. Everybody, what's 4 minus 1 minus 2? Oh, now it's really a hard problem. Can I multiply 1 times this parentheses? Negative 2 plus 3i. It is not okay to leave it like that because it is a complex number. We must separate the complex numbers as the real part, so negative 2/13 plus 3/13 times I. So must write separately. If we had done it and multiplied by minus 3i plus 2 over minus 3i plus 2, at this step, we would have had a positive 2, a minus 3i, and a minus 13. So when we simplified and separated it, we would have had the same thing. All of the signs would have just been the opposite, but we would have gotten the very same final answer. Questions with that? Okay, we're almost there. Just one more topic for us to review today. Solve by completing the square. So I have a quadratic equation. Tomorrow we will review using the quadratic formula to solve these. Today we're reviewing the process of completing the square to solve them. We will be doing lots of problems with completing the square next semester. It is the best way when we are doing equations of hyperbolas and ellipses and circles to be able to do that with completing the square. So for right now, we're just reviewing solving equations. Anybody remember what we need to do first with this one? Negative 2x plus 5x squared plus 3. What do we need to do with that? Keep. Okay, we need to get it in standard form so that we're starting off with the x squared. Do we start with 5x squared when we're completing the square, though? What do we want to have instead? We want to just have 1x squared, so we're going to have to divide by the lead coefficient. So 5x squared minus 2x. And we also want the constants over on the right-hand side. So we're going to need a minus 3 over here. We just said we don't want to start with 5x squared. We want 1x squared, so we divide everything by 5. And then I'm going to write this just a little more neatly so we can see what we have. We have 1x squared minus 2/5 x equals negative 3/5. Completing the square means we want this to be x plus or minus something squared. Do any of you remember how we figure out what goes in this parentheses that I just wrote? Getting a couple of hands up. So Jimby, what do we need to do?
You multiply 2 divided by 5 by 2.
Actually, the negative 2/5 we multiply by a half. We take half of it. So we're going to take a half times the minus 2/5, which gives us minus 1/5. So far, so good. Okay, then we FOIL out this parentheses that we've got. X minus a fifth times x minus a fifth gives us x squared minus a fifth x minus a fifth x minus 2/5 x. And finally, minus a fifth times minus a fifth gives us plus 1/25. So if we FOILed this parentheses, we would have this line that I've now written, including the red part. But I can't add 1/25 to the left unless I also add it to the right. Kind of coming back to you guys from last year? Good. Then we need to get a common denominator over here. So I'm going to multiply that numerator by 5/5, which means that I have this on the left, x minus a fifth squared, is 1 minus 15, gives me negative 14/25. Parentheses squared equals. What's next? What do we do when we have parentheses squared equals? Ian, you remember? We're going to take the square root of each side, except whenever we do that, we have to also remember that we are taking the plus or minus square root. So I have x minus a fifth now, because square root makes this square go away, and I just have x minus a fifth. I've got a negative sign inside that square root, so what does that mean I have? That means I have an I, so I have plus or minus the root of 14 over the root of 25 times the I. Last step, I want just x equals. So I add the 1/5 to both sides, plus or minus square root of 14/5 times I. It is already separated real and imaginary part. Anybody with questions on what all we have reviewed today?